Hello, today we're looking at the stages of production, packaging and labelling of cheese. This was asked 8 years ago, 2017, on question 2 on section B. So in my calculation, that works out to be 8 years ago since we have seen the stages of production, packaging and labelling of cheese. Now, manufacture of cheese is exactly the same as the stages of production. And in 2017, students were allocated 18 marks for part B of that question 2 on section B. 7 by 2 marks, that's 14 out of the 18, went for the stages of production. And in the official marking scheme, there were keywords highlighted, which we'll zone in on today. 2 marks went for packaging, 1 good point. 2 marks went for labelling, 1 good point. So it's worth keeping an eye. Remember as well that cheese happens to be a food that has been processed to prolong shelf life. In other words, we can prolong the shelf life of milk by converting it into cheese. It's also considered what we call secondary processing, which we will cover in the chapter Food Processing, Packaging and Labelling. And this is where we take a food that has undergone primary processing, like raw milk being pasteurised, and then secondary processing, the pasteurised milk is turned into a new food, i.e. cheese. Now, there are lots of artisan cheese producers around the country creating magnificent cheese. And most of those, if not all, are going to use raw milk, which is unpasteurised milk. For a couple of reasons, they want to stick, I suppose, to the traditional skill of cheese making in Ireland, where raw milk or unpasteurised milk could have been used, but also it has a significant effect on the flavour of the milk if you use raw milk. In our case here, and in the instance that you were asked about the stages of the manufacture of cheese going forward, we're looking at using pasteurised milk. So refer back to your chapter on milk just to know the temperature. Now, as you would expect, I'm off with my doodles. Now, you can learn the stages of manufacture or production of cheese from our chapter. You can learn packaging and labelling from there also. I'm just going through the little doodles here just for the purpose of learning, but you won't be expected to draw any diagrams in your exam. So the stages of production of cheese, and we're going to say, for example, cheddar cheese. So we start out with a vat, a large stainless steel vat of, say, pasteurised milk. Just quick revision there, pasteurisation involves heating milk to 72 degrees centigrade, holding it there for a max of 25 seconds and then dropping the temperature to 10 degrees centigrade. Now, as we know from our study of milk, pasteurisation destroys all pathogenic bacteria, most non-pathogenic bacteria, but some non-pathogenic lactobacillus survive. And remember, we used a word, culture. Culture is referring to the family or the group of bacteria, and the one we most likely to find in yogurt, cheese, milk products is the culture lactobacillus. And remember, we have thousands and thousands of strains of lactobacillus. I suppose you could refer to that to like different varieties or members of the lactobacillus culture or family. So the first thing that happens is that the pasteurized milk, we're going to say lactobacillus bacteria are added. Now, I'm sure you're saying, why are they adding lactobacillus bacteria to the pasteurized milk? Are there not some lactobacillus bacteria in pasteurized milk because they've survived the pasteurization process? Yes. However, the lactobacillus bacteria are added, or you can refer to them as lactic acid bacteria. are added, and it's it's always different strains of the lactobacillus. Now, just to help you understand what I'm talking about here, when you and I go to the supermarket and we're at the section of the shop where we have cheese, none of the cheese looks the same. They're all different shapes and sizes. Some cheeses like Edam are round, others are quite flat, like Camembert. Some cheeses have holes in them, some are very crumbly like feta, some have a squidgy texture like mozzarella, some have a more dry effect like Parmesan and cheddar. So we've all different shapes and sizes and different textures of cheese. And while there is one magic ingredient that is common to all, which is rennet, which we looked at in our previous lesson, rennet is used in all cheese to convert the milk into curds and whey, and the curds are what makes the cheese. However, it'll be the different strains or members of the lactobacillus culture that will influence the taste and texture. Now, most cheeses will have a number of different strains of lactic acid bacteria added, but I'd like you just to show off a little bit there and say, for example, Lactobacillus helveticus is a strain of lactobacillus added to cheddar. Now, there are other strains of lactobacillus added to milk to make cheddar, but I just think it looks good on an exam, just to show that actually you know that it's the different strains of lactobacillus that will influence the taste and texture of different cheese. So that is Helveticus, and of course it's spelt incorrectly, so we need to sort that. So I'm just going to rewrite that. So Helveticus, here we go. So Lactobacillus, Helveticus. So that's our first stage. Secondly, the milk is heated to 30. So milk is heated to 30 degrees centigrade. Now this is significant because we're going to add the magic ingredient next. Now I keep saying magic ingredient, but it truly is, because it is the addition of the rennet. Remember, this contains the enzyme renin, and it's the enzyme in the rennet that is going to help convert the milk into curds and whey, specifically curds to make the cheese. But rennet contains the enzyme renin. Enzymes, those of you that study biology, are very specific to temperature. And if you heat enzymes beyond 40 degrees centigrade, like renin, which is an animal enzyme, you will denature the enzyme. You will make it inactive and it's not going to work. So it's important that that milk is not heated to a particularly high temperature to avoid the denaturation of the enzyme in rennet. So the cheese is going to take a couple of days to produce, because that milk, which has had the strain of bacteria or strains of lactobacillus added, has been heated to 30 degrees, and then the rennet added. Hours later, so the following day, when the cheesemaker comes back to the vat of milk, we no longer have a vat of liquid milk. We'll note that the milk has now divided into two very distinctive layers, and they are curds and whey. Now the curds resemble set yogurt, or if you are familiar with cottage cheese, you know the texture of cottage cheese. Well, cottage cheese is chopped curds. So can you imagine that tub of cottage cheese uncut? You have this semi solid type mixture, which are the curds. The whey, on the other hand, is a milky, watery liquid. So you have these two distinct layers. Now, what has brought about the two distinct layers? Well, the rennin, which is the enzyme, either added because of natural rennet from the lining of the calf stomach, or rennin produced by biotechnology engineering in Moore Park in Cork. Either way, this enzyme will coagulate the milk protein caseinogen to form a new protein which is called casein. Now, when we have the alteration of the structure of a protein producing a new protein, we refer to this as denaturation. So denaturation takes place due to the presence of the enzyme rennin. Remember, we referred to 3 other causes of denaturation in our protein chapter: the addition of acid, agitation, and also the application of heat. So we have caseinogen, the protein in milk, denatured to a new protein called casein. Our next stage is that the curds and whey are separated. Now, what happens, the whey, is that the whey will be dried into what is called whey powder. Now, I'm sure most of you are familiar with that word, whey powder. Certainly anyone who goes to the gym will be familiar with whey powder. We can even get it now in various different colours, from vanilla to strawberry, etc. But for many, many years, whey powder was high in protein, obviously, but it was used in just animal foodstuffs. But over the years, we have been using it in human foods, and why wouldn't we when it is so high in protein? But like that, since people have started to go to the gym more, you have people just buying pure whey powder for the high protein content, where they want to build muscle, etc. So now we're just left with the curds. And the first thing that happens with the curds is that the curds are chopped. And they are put into, so they're chopped and they are into blocks. So they're chopped. So they're chopped and they are left. While they're chopped, whey is going to be released. Lost my train of thought there for a second. So the curds are chopped to release more whey. We refer to this as cheddaring, the release of whey from the curds. And that was a key term that was asked as part of the marking scheme in 2017. And next we note that the curds are heated to 30 to 40 degrees centigrade. Then they are pressed. To varying degrees to allow more whey to be released. Then we note that the 2% salt is added, and the purpose of the salt is to firm up the curds even more. Then the curds are placed in moulds. Now, when we say they're placed in moulds, it means they're put into various different shapes and sizes. So some moulds will be wide, others will be not so wide, some will be high, some will be low, etc. In the case of cheddar cheese, the curds would be chopped into blocks and they would be laid on top of each other. They would be turned every so often, and this is to allow more whey to be released, i.e. more cheddaring takes place. The curds that are placed in moulds will be pressed to varying degrees. So once they go into the mould, if they want a hard cheese, they will press the curds quite a bit to take out as much whey or liquid as possible to end up with a dry cheese. For a semi-soft cheese, the curds will be pressed a medium amount, and for soft cheese, the curds are barely pressed because you want a high moisture content in a soft cheese. Then what they do is they unmold cheese that has been put into these molds. Some of them are sprayed with hot water to help form a rind. Others are dipped in wax. So some examples would be Edam cheese is dipped into a hot red wax. The French semi-soft cheese Port Salut is dipped into an orange wax, and then that'll lock in moisture. Then they're left to ripen and mature anywhere from 2 months to 2 years, and the idea is to develop the flavour while they're left to ripen, and the longer we leave the cheese, the stronger the flavour. Now some cheese, for example, like a really good Parmesan, the Parmesan could be left in an environment that is strictly monitored. Most cheese is left to ripen and mature in an environment between 12 and 15 degrees centigrade, but it must be monitored constantly because you don't want a situation whereby if the temperature is altered, then you have unwanted mould growing on the cheese. Like I said, Parmesan, you could have a 7-year-old Parmesan, you could have a 12-year-old Parmesan. There's even the oldest Parmesan 20 years old, and people who are really into cookery, you know, or chefs, etc., they're hundreds and hundreds for a wheel of good Parmesan. So for some people, a really nice Christmas present would be a big wedge out of an old wheel of Parmesan, and you know, they would have an appreciation of the aging process, the flavour, etc. In some cases, what will happen if it's not a Parmesan or a cheddar, the unmoulded cheese is injected with, say, Penicillium mold spores. If you want to make Cashel Blue or Stilton, because the Penicillium mold spores will start to grow inside in the cheese and produce this veined effect, and also give a characteristic flavour and texture to cheese. Now, that's just the brief outline of the stages of the production of cheese. What you must really do is learn the stages of production from the chapter in your book, which we're going to go through now. So first of all, we note that milk is homogenized, passed through tiny valves to break up large fat globules into minute globules. Then the milk is pasteurized, which we had earlier, heated to 72 degrees for 25 seconds, dropped to 10. Secondly, we said a culture of Lactobacillus bacteria is added. Lactobacillus helveticus would be the particular strain of, or one of the strains of lactobacillus or lactic acid bacteria added to the milk. And the strain, remember, or the strains of lactobacillus will influence the taste, the texture, and of the cheese. We know the bacteria feed off the lactose in the milk and convert to lactic acid. Next stage, number 3, the milk is heated, we said, to 30 degrees centigrade, and this temperature is significant because you want to avoid the denaturation. So I'm going to write that there, to avoid denaturation of the enzyme rennin. Then number 4, the rennet is added, which has another name we know called chymosin. But I'm actually going to highlight that because you would have to mention rennet. You would have to mention 30 degrees centigrade. You would have to mention the addition of lactobacillus added to the milk. Also the fact that the milk is pasteurized, and also that the bacteria will feed off of the milk sugar in milk and convert it to lactic acid. So they are key points. We said that the enzyme rennin coagulates the milk protein caseinogen to form casein, and that would be, as well as mentioning the rennet, which is very important. You'd have to mention about the caseinogen being denatured into casein. Then we note that the curds and whey are formed after the protein caseinogen is coagulated or set into casein. The curds and whey are separated, and we said when the curds are chopped, you're going to have the release of this whey or liquid, and this is called cheddaring, and that's a significant word as well. Then the curds are heated to 30 to 40 degrees Celsius to squeeze out more whey. Then in the case of our cheese, the curds are cut in blocks, piled on top of each other, and they're turned regularly. So I think we might say that they're cut in blocks, piled on top of each other, and turned regularly. And by turning them regularly, more whey is drained out, which we said refers to more cheddaring. Don't forget the 2% salt is added, which will firm up the curds and add flavour. Then the curds are placed in moulds, the pressed curds. They are then sprayed with hot water to form a skin or a rind. So we're going to mention rind there. Say a rind on parmesan and so on. And then others can be dipped in hot wax. So sprayed with hot water or dipped in wax. I actually saw a programme about an artisan cheese producer, and what they were doing was they dipped the pressed curds. So the curds being pressed into these moulds, and when they were unmoulded, they were dipped in a pear cider, just literally in and out. And the whole purpose behind it was that the natural mould spores in the air would be attracted, specific ones would be attracted to the pear drink, and in turn would give a very unique flavour to the artisan produced cheese. So we said the cheese are removed or unmoulded, so I'm just going to highlight there, and left to ripen and mature between 12 to 15 degrees Celsius from 2 months to 2 years. So I'll also put beside that they are removed or unmoulded. In other words, they're taken out of their shaped containers after they have been sitting there for a number of hours, even a number of days. They're unmoulded, and either they're sprayed then, we said, with hot water and so on. The penicillium mould can be injected into the cheese for, say, blue vein cheese like Cashel Blue or Stilton, and the cheese is graded according to colour, flavour and texture. So your last point would be leaving the cheese to mature anywhere from 2 months to 2 years between 12 and 15 degrees Celsius. Now again, it does depend on the cheesemaker, but that's just the average temperature. and that the cheese is left to mature at, and it's constantly monitored. So that has to be learnt for Leaving Cert 2025 due to the fact that it's been 8 years since it has been asked. Now, the packaging of cheese was also asked in 2017 on question 2B, and so too was the labelling. Now we're going to look at a few. In 2017 they only wanted one type of packaging. So the first one is vacuum packing in heavy duty plastic, so things like cheddar or parmesan. Secondly, you have packing cheese in a plastic bag filled with brine, which is salted water, and that would be for cheese like buffalo, say mozzarella. Thirdly, you have the packaging of cheese in plastic tubs. They can be circular, or they could be oval in shape or rectangular in shape in the case of cream cheese. There's usually a foil covering over the cheese and then the plastic lid. And fourthly, then you have waxed paper, also used to wrap cheese. You sometimes see it in the supermarkets over cheddar. So there are 4 examples. You had to give one. Now I would probably have given at least 2 different types of packaging for that particular answer. I'd always be afraid. Remember, err on the side of caution. And finally there, the labelling of cheese. So learn, I would say, 4 different pieces of information from the label. So first of all, the type of cheese, and then give an example like cheddar, parmesan, mozzarella, cachet bleu, whatever it happens to be. Then you have the brand. So you might have Macroom buffalo mozzarella. You've also got Dubliner cheese. You've got, so I'll just take Dubliner cheese would be another brand. You've got Charleville cheese would be another brand. Then you have the date stamp, and this is the durability, how long it's going to last. And because it's a perishable cheese, we're going to see use by. You can change that there to 25 just to keep it up to date. And finally, since December 2016, all prepackaged foodstuffs must have nutritional information per 100 grams. So it's important to mention that. The macronutrient content, like the protein content, the lipid content, saying what amount of saturated fat is present, the salt content also. Why did I not mention carbohydrate? Because there's no carbohydrate in cheese. Why not? Because the bacteria feed off the lactose, milk sugar, carbohydrate, convert to lactic acid in the early stages of cheese production. So that's the end of today's lesson, but certainly I would strongly advise that that is learned for next year's Leaving Cert exam. So that is the end of today's lesson.